It is almost 7:08. Nobody has joined. We'll wait for 12 more minutes. Around 7:15 or 7:20, if nobody joins, we'll start the recording. Yeah. Welcome, Surekha. Thanks for joining. So I believe we can start our today's session. Let me share my screen.
Yes, sir.
Hope it is visible and I am loud and clear.
Yes, sir.
Okay. So we'll start. We will not wait for others.
Yes.
So, uh, if some portions they miss, they will watch the recording. No issues with that. So let's hope you don't have any doubt regarding the last class, because last class probably you were attending, maybe students attended. So if you have any doubt, because last class student raised one question, he actually contacted me over social media. He actually told that he's having some problem regarding one question, one assignment question basically, and that question was basically wrong. So I actually discussed in the last class. So what should be the correct answer? What is the way to solve this kind of problem? It was I'm not exactly. I am not remembering what was it. It was probably uh, tapered. Yes. It was a problem based on artesian well. So how artesian there are test wells. Those are bored at the side of the probably week 3 or week 4 assignment. There was certain problem. So actually I discussed it in the last class, and also you will saw the students question in the discussion forum. So if you have so the answer sheet that has been shared, that is the answer that is there, that is also wrong for that particular assignment. I have discussed it in detail, so please go through it if you have any doubt with that. If you have understood that it was wrong, then no issues, because no options given in the assignment was matching with the answer of that particular problem. Yes, I remember in the answer sheet it was 2.05, but I mean that would not be the correct answer. The correct answer will be 3.65 or something like that. That student calculated it correctly. But no issues with there is a very small marks there, that may be plus or minus. Okay, so we'll start our today's session. I'll welcome you, and my name is Shutanu Sadhukan. I am a teaching assistant under the PMRF scheme, and I am a facilitator for the NPTEL live interactive session of week 5. The course code is AR18. The title is Urban Utilities Planning, Water Supply and Sanitation. And the instructor is Dr. Debapratim Pandit, who is a professor of IIT Kharagpur at the Department of Architecture and Regional Planning. So here are we? We are at the last session of this month. It's the 5th week. All the 4 weeks recordings and lectures, everything, those are uploaded already in the portal, and also the recordings are uploaded in my YouTube channel. That has been also shared with you through the Excel sheet, I believe. If you are having any problem regarding accessing that, please tell me. I'll repeat the process of accessing the same. And one more thing is that the feedbacks regarding the weekly interactive session and as well as Dr. Pandit's lectures are circulated to you via email. So we highly encouraged you to watch the recording session, watch the lectures, and gives feedback accordingly so that we can improve our session as per your expectations and requirement. Okay. So now let's start. So in the last class, I actually told about what a grid chamber is and how the grids are separated with the help of from the water. The grids are separated with the help of this chamber, and pure water is taken out. So now in this section, we will solve a very simple problem based on this grid chamber. So our first problem is something like this. For a grid chamber, given a flow velocity of 0.45 meter per second and a detection period of 45 seconds, calculate the length of the tank in meters. So I'll wait for 2 minutes, then I'll proceed with the solutions. It's very simple problem, direct calculation or answer based problem like that way. I mean, based on the question itself, the answer is, I mean, you can guess the answer. The detention, okay. So I'll repeat what is a grid chamber and the parameters also to make you clear. So this is called as the flow velocity 0.45 meter per second and detention period is 45 seconds. So what is basically a grid chamber? It is a chamber where water containing grids, that is very large particles, that is contaminated with these large particles, but they are not dissolved in water. So these are undissolvable particles. So they non-dissolvable particles, they actually if we keep the water for a very long time, they will just they will just get precipitated at the bottom of the grid chamber. So what is happening here? So basically the inlet flow water comes at a very high speed, but after entering the grid chamber, it encounters a large surface area. So the velocity suddenly drops. In our case of the problem, it is coming at 0.45 meter per second, and after entering the chamber, the velocity is falling. So the velocity is falling, and the detention period. So the water particle from this distance to this distance, it takes 45 seconds as per our problem. So once the velocity gets decreased, there is a concept called as the settling velocity. So if the kinetic energy is suddenly released, what happens that the particles, they started settling, and compressed air sometimes is also uh, purged within the chamber in a counter current direction, that is from bottom to top, and the grids settle from top to bottom. In this way, these are get separated at the bottom, and grid free water is taken outside. Now the grids, those are deposited at the bottom. After a certain period of time, one can open this valve and the grids can be taken out. It's a kind of batch cleaning operation, we can assume. And also sometimes if there are fats, oils and grease, they actually floats at the top of the water surface. That can be taken out by some other arrangement. Okay, so now here what they are asking, they have given you the velocity, they have given you the time, you just have to calculate the length of the chamber. That's all. So it's very simple problem, I guess. So just okay, I'll wait for 1 minute. Just do the math and tell me the answer. Keep a copy with you. Copy or calculator also you can use, no issue with that. Yeah. So okay, I'll proceed with the answer. So the solution is something like this. Flow velocity is given as 0.45 meter per second and detention time is given as 45 seconds. So length is nothing but the flow velocity into detention time, which is nothing but equals to 0.45 into 45 meter, that is 20.25 meter. Both are in MKS unit or SI unit. So 20.25 meter is the answer. Now, next question is you have to select the correct statements regarding the grid removal. It is an MSQ. That is multiple select question. If you are Sureka, what was your background? I forgot. Are you a BTech student or you are an industry professional? Have you given GATE exams? So if yeah, just your voice just got cut. Okay. No issues. So if you have student given the GATE exam, you might have encountered this kind of question. This is called as the MSQ or multiple select question, where more than one option may or may not be correct. So the statements are: A is in aerated grid chambers. There are zero moving parts below the water surface. B is grid chamber is usually installed after primary sedimentation tank. C is grid chambers are used to remove oil and grease from the wastewater. D is the purpose of the proportional weir at the end of channel type grid removal system is to measure the rate of flow inside the channel. I'll wait for 1 minute for you to identify the correct statements regarding grid removal in the grid chamber. I showed you the aerated grid chamber where the air flow is done from bottom to top. It is an optional thing, and they are telling that there are zero moving parts below the water surface. Just you have to imagine the picture. That's all. And option B is grid chamber is usually installed after primary sedimentation tank. Option C is grid chambers are used to remove oil and grease from wastewater. Sometimes they are used, and that I also showed to you. And D is the purpose. This is the main purpose of the grid chamber. Sometimes it is used. The purpose of the proportional wear at the end of the channel type grid removal system is to measure the rate of the flow inside the channel. Okay, so I'll tell you the answers. So option A and D is the correct answers. C is sometimes used, but it is not the main purpose of the grid chamber. So that's why it is not a correct answer. if the oil and grease quantity present in wastewater is very large, then one cannot use grid chamber for removing the oil and grease. Okay, and yes, it is also not used after the primary sedimentation tank. It is used before. Yeah, do you want to say something? And below the, I actually, if you want to say something, you can type because your voice is not coming.
No, sir.
Okay, okay, okay. So the aerated grid chambers, zero, there are zero moving parts below the water surface. If you imagine the picture, then you will understand. And whenever a proportional wear is used, not only in grid chamber but also in any kind of water treatment unit operation, so that is to calculate the rate of flow only, to measure the rate of flow only inside the channel. So it is to not only for grid chambers but also other kinds of water treatment unit operations. Okay. So now next you have to select the incorrect statements regarding the screens and their purpose in wastewater treatment. It is also a multiple select question, so more than one option may or may not be correct. Option A is screens prevent any interface to treatment. Option B is screens are used to protect process equipment. C is screens are a part of secondary treatment. And D is there is no head loss when sewage flows through them. I will again wait for 1 minute. You have to identify the incorrect statements here, not the correct one. Or more than one statement may be incorrect or may not be. Maybe one statement only is incorrect. It is also possible. Okay. So if you are not able to give the answer, I will tell. So option C or D are incorrect statements. Option A and B are correct. So screens prevent any interface to treatment, and screens are used to protect the process equipment. These are true statements, because you see why the screens are used to, for example, there is a screen that is called basically your pocket filter, which is usually used before your pumps. So those type of screens prevent larger particles to go into the impeller of the pump so that it don't damage the impeller of the pump. And option C and D are screens are a part of secondary treatment. It is not. It is a part of primary treatment. So C is incorrect. And there is no head loss when sewage flows through them. It is incorrect because sewage flow actually causes a large amount of head loss. Not I mean not a small amount of head loss, because sewage has got a it is kind of slurry. It has got a high density. It increases the density of the fluid within which it is present. So in case of water, sewage basically causes more head, I mean a large amount of head loss. Head loss means a pressure drop, nothing else. Head loss means energy loss. So head is just a form of energy, where pressure is converted into height or length unit. So it's just called as the head loss. Okay. So now we will move on to our next question. It's an MCQ or a multiple choice question. That means one option will be correct. So which water supply system is best suited for a city where the source of water is at an elevation higher than the city level? Okay. Yeah. So this you have to answer. Okay, so options are: A is lifting system, B is gravity system, C is dual system, and D is flowing system. Which system is best suited for a city where source of water is at an elevation higher than the city level? That source may be artificial, maybe artificial means man-made, or that may be natural also. So source of water may be naturally located at a very high, region, that is maybe a mountain or hilltop, and from there the water is being supplied to local cities. It may so happen, or it may so happen like this way, that maybe it's a plain where municipality is taking water from the river, surrounding river or water body, and after treatment or something, it is elevating that water to a certain height. Yes, elevated height, so from the city level, then it is supplying that water. Anything may be possible. So what is the name of the system or a particular water supply system? That you have to answer. I'll wait for 1 minute for you to type the answer in the chat box. The correct option. Remember or not? Okay, so I'll proceed with the answer. Okay, you have told us dual system, but it is, I don't think it is a dual system. So let's see the explanation. The gravity system is suitable if the source is higher than the city and water flows in mains due to gravity with no requirement for pumps. So the correct answer is the gravity system. If you have watched my previous recorded lecture, so there I was talking about the different principles of hydrostatic equilibrium of liquid. So not different principle. This is only a one single principle. So what happens in this case? Here, water has a property to come into equal heights, which is called as the hydrostatic equilibrium. So by using that principle, domestic water supply from municipal tanks, it is done. So what is happening here? So water is stored at a elevated height after the treatment from the source of the water by the municipal corporation, and from that elevated tank water is supplied to households. So the tank must be located at a higher height, which is higher than the household. So why the water will flow? Because of this hydrostatic equilibrium property of liquid, because of the presence of the gravity basically. If the gravity is not present, water will not to come into the equal heights. So because of the gravity, the hydrostatic equilibrium is possible. So that's why this kind of system is called as the gravity system. So welcome Deepti Rani. We have covered certain questions. This was being discussed because of this question. So where it was asked, which water supply system is best suited for a city where the source of water is at an elevation higher than the city level? So it's called as the gravity system. Okay, so where the domestic water supply from municipal tanks is one kind of example of such gravity systems that we just discussed. Okay, so now let's move on to our next MCQ. Which one of the following statements is incorrect about pumping stations? Option A is it can be located near water treatment facility. Option B is it can be located near water storage facility. Option C is main pump stations supply water to distribution system. And option D is pumping stations are not required in sewerage networks. So can any one of you tell what is the difference between sewage and sewerage? Before answering the question, can anyone of you elaborate? Recording have I started? Yeah, yeah. Okay, so I'll tell what is difference between sewage and sewerage. Basically, sewage is the material, the fluid containing the solid waste that is flowing, that is called as the sewage. But sewerage is the pipes, big hume pipes through which the sewage material flows. So the network is called as the sewerage, the piping network through which the sewage flows. And those pipes are basically made of those are circular pipes which sometimes you may see in roads also. Whenever the roads are dug up by the municipal corporation, then you will see the sewerage pipes are basically made of reinforced concrete. So by joining one by one, they actually forms this network. Okay, through which the sewage basically flows. So this is the difference between the sewage and sewerage. Sewerage is the piping system through which the sewage flows. That's all. Now, what they are asking in this question? So you have to identify the incorrect statements about pumping station. So among these four statements, which one is incorrect? So pumping station can be located near water treatment facility or water storage facility. So where it can be located? And main pump station supply water to distribution system, and pumping station are not required in the sewerage network. So which one do you think is incorrect? I will answer after 1 minute. You can type the option in the chat box. Okay, I'll give the answer. So the explanation is something like this: pumping stations are also required within the sewerage networks for lifting sewage, because as I told, that sewage in one of the earlier questions, you saw that sewage causes a lots of pressure drop. So without excess energy imparting into the system, without pumping system, it cannot be, you cannot move this sewage basically. So for lifting the sewage to a shallow sewer, pumping stations are required, and also it is required for conveying to the STP, that is sewage treatment plant, or outfall from low-lying areas to existing sewerage infrastructure, and or from remote areas not linked with the sewerage network. From the to transfer that sewage from remote areas to the sewage network, also pumping is required. So pumping, all these points basically clears that pumping is an essential thing for sewage pumping. So option D is basically a incorrect statement. Okay, it is the answer. All the other statements are correct. So pumping station can be located near a water treatment facility. It can be located near a water storage facility also, right? And uh, main pump station supply water to distribution system. All right. We'll move on to our next MCQ. So service lines are designed to carry how many times of the average demand? Option A is 3, option B is 2, option C is 5, and option D is 6. You can type your answer in the chat box. I'll wait for 1 minute. How many times of the average demand of water basically can be carried by the service lines, or they are designed to carry how many times of water with respect to, or as compared to the average demand. If the average demand is, let's say, D, then service lines are designed to carry how much amount of water? Is it 3D, 2D, 5D, or 6D, like that way? Okay, so should I wait for? Okay, I'll tell the answer. So the explanation is something like this. Main lines are designed to carry 3 times of the average demand, whereas service lines are designed to carry 2 times the average demand. So if the average demand is A, the main lines will carry, are designed to carry maximum 3A amount of water, and service lines are designed to carry maximum 2A amount of water. That's all. So option B is the correct answer in our case. Okay. Now we'll move. Any doubt? Whatever we have discussed till now. So Deepthi, have you gone through last day's lecture? I don't remember whether you joined or not. Probably you didn't join. So if you have any question regarding the watching lecture, you can ask now. Or if you don't have any question, or if you have not watched it yet, then you please go and watch, and you can raise the question in the discussion forum, or also in the next class also. No issues. Okay, so we'll move on to our next MCQ. High lift pump, you have to fill in the blank. So high lift pump pumps directly into the distribution system. B increases the pressure located anywhere in the pipe. C is used for lifting sewerage to a shallow sewer, and D is used to convey storm water to the STP and or outfall. So what is the function of the high lift pump? That you have to select from the following options. Uh, I have already told what is basically your storm water in probably 2 or 3 lectures earlier. So the storm water is nothing but the rainwater only, but after falling to the ground. So after falling to the ground, whenever the storm water flows on the ground or through the drain, then it is called as the, then that rainwater is called as the storm water, nothing else. So it is rainwater contaminated with the dust that is present on the ground. That is called as the storm water. So whether high lift pump is used to convey that water to STP or outfall, that you have to determine, and whether it is used to, it is MCQ, so one question, one answer will be the correct option. Whether high lift pump is used to lift the sewage to a shallow sewer, whether it pumps directly into the distribution system, or whether it increases the pressure located anywhere in the pipeline. What is the function of the high lift pump? Okay, so if you are not able to answer, I will, should I wait or? Okay. So the explanation is something like this. High lift pumps pump directly into the distribution system, where the pumping station may be a part of other structures, but it will directly pump into the distribution system. Booster pumps increase the pressure and located anywhere in the pipeline, generally at areas with topographical difference or during peak hours when flow requirement is more. Understood? So what will be the answer? Option A is the correct answer. High pump pumps directly into the distribution system, maybe from outside of the distribution system, or maybe as a part of the structure of the system. Okay. And option B is true for booster pumps, which are basically used if the piping network is very complicated, then pressure drop is a high pressure drop. High pressure drop may occur, or high head drop, head or pressure drop, you may call it whatever you like. So it may occur based on many factors. If the inner surface area of the pipe is very rough, or if there are many bends in the piping network, or if the length of the pipe, that is, you have to pump the liquid in a water to a very large distance, then pressure drop may occur. It generally happens in our households also. So I don't know whether you live in urban area or rural areas. So if you live in urban area, sometime you will see that the municipality supplies water, and whenever you are using that water in your household, if you open too many taps, multiple taps, you will see the pressure in one tap gets reduced. So in this way, the pressure drop may occur. So in industry also, if there is a pressure drop, but industry cannot afford that. We can delay our household activities, but industry, it is associated with your money. Every time, each and every time costs money. So then what they do, they use booster pumps to increase the pressure. And also sometimes whatever happens, if the requirement is more, many more households is opening the taps, then what happens, the water pressure gets reduced. Welcome, Prithika. I'll recommend the last 45 minutes lecture. You can watch from the recording, or you may go through the slides whenever it will be uploaded. So as I was telling, so booster pumps function is like that way, to increase the pressure, and hydraulic pump is used for directly pumping into the distribution system. Okay, just wait a minute. Okay, so now we will move on to our next MSQ. It is a multiple select question. Is it visible? Here. So more than one option may or may not be correct. Which one of the following directly leads to increase in urban water demand? You have to choose the correct option. So first option is melting of glaciers, population growth, more consumption oriented lifestyle changes, and population reduction. Which one of them directly leads to increase in urban water demand? You can type your option in the chat box. I'll wait for 1 minute. What is the cause of urban water demand that you have to identify? So whether melting of glaciers increase the urban water demand. Glacier, you know, what is the glacier? If you don't know, tell me. Population, whether population growth leads to urban water demand, or population reduction leads to the increase in the demand, or more consumption lifestyle. So more than one option may or may not be correct. If you are unable to answer, it's easy question, I think. You should type in the chat box. Or tell me if there is any understanding problem, or if okay, Pritika is telling Q and R. Yeah. So it's pretty obvious. So the explanation is something like this: lifestyle changes and population growth lead to increase in water demand. If the population reduces, it will not increase the demand, and glacier has nothing to do with the urban water demand. So Q and R is the correct answer. as you have correctly told. Now we'll move on to our next MCQ. So, which one of the following factors does not affect runoff estimations? Option is number and size of ditches. Option B is profile of artesian well. Option C is area, slope, and shape of the catchment. Option D is intensity and duration of the rainfall. I'll wait for 2 minutes for you to answer. Read the question and you can type your answer in the chat box. I actually in the last class discussed the artesian wells in a very detailed manner and what are the formulas that govern the artesian wells. Yeah. I wish to repeat this in this class also. Let's see whether I can do that or not, as very less people attended the last class. So yeah, it is 6, yeah, and let's take a picture from here. It's good, no? Have you given your answer? Let's see what it is. Okay, nobody has answered. So here is the explanation. Different factors affecting runoff estimations are area, slope, and the shape of the catchments, soil types, obstructions, land usage and land covers, initial states with respect to wetness, intensity, and durations of rainfall, number and size of ditches, atmospheric temperatures, humidity, and pressure. So all of the option A, C, and D are the correct. So they actually affects the runoff estimations. Only the thing that don't runoff means what? So if the rainfall is occurring, if the water is getting runoff in nearby water bodies, that is what meant by this. So all these other things, the number of size and ditches, area, slope, shape of the catchments, and intensity and duration of the rainfall will obviously they will affect the uh, estimations of the runoff or the runoff quantities. But what it will not affect, just what it will not get affected by, that is your profile of the artesian wells. So option B is the answer which does not affect the runoff estimation. Now I actually in the last class I told you the difference between the aquifers which are confined and unconfined in nature, and how the artesian wells are dug, and why, due to the hydrostatic equilibrium, water flows through the artesian wells. And we also solved problem. This was basically the problem was basically based on these concepts. The unconfined aquifer. This is the confined aquifer, but the problem was based on unconfined aquifer. So the one formula is there. It is called as Thiem formula. That formula is used for solving these kind of problems. So for a confined aquifer, there is different Thiem's formula, and for unconfined aquifer, there is different Thiem's formula that we discussed in our earlier class. So okay, okay. Just sorry for that. Yeah. So this is how an artesian oil looks like in reality. So if the from the underground, if the oil, if you just dig the oil, the water will flow like that way. And in winter season, it will be frozen. The flowing oil will get frozen. After getting frozen, it looks like this way. Okay. So now we will move on to our next MCQ. So water demand is mostly dash on or to water price. So you have to fill in the blank. A is inelastic, B is elastic, C is proportional, D is dependent. So what is the nature of the dependency or function of water demand on the water price? So water demand is a function of water price. You have to identify the nature of the function. So whether it is elastic, inelastic in nature, proportional, or just dependent. You cannot determine the exact nature of the function. So which option is which one is the correct answer? Which option is correct? That you have to identify. I will wait for 1 minute. You please type the option in the chat box. Welcome, Aruna. The question is on the screen. It is a fill in the blank question. So you just okay, Deepthi rejoined. Okay, I'll wait for 1 more minute. Okay, Surekha is telling us dependent, just dependent. Okay, so okay, I'll wait for 1 more minute. Aruna, have you gone through the last lecture on artesian oil problem was discussed there? So the question, the answer sheet that was circulated with respect to the answer of the assignment of that particular week, the all the options were wrong there. The question number was 14, most probably, as far as I remember. So I discussed in detail in the last class that it was basically wrong. So if you are confident enough in your method or procedures, then you don't have to worry about the answers for just for 1 or 2 marks. You don't have to worry about that. Okay. So now this question, let's see the detailed explanation. So water demand is mostly inelastic in terms of water price. So option A is the correct. So whatever, I mean, okay, yeah. Dipti has answered it correctly. So water demand is mostly inelastic. Okay. Now we'll move on to our next. Okay, so you have to identify the distribution layout of the following illustration. So one illustration is given to you. You have to identify the distribution layout. So whether I should give the options or by just looking at the distribution layout, you can, I mean, looking at the layout, you can tell what kind of distribution it is. You have to, I mean, remember the names or terminologies. Those are used for the for defining different kinds of distribution layouts. So what kind of this is? Should I give the options, or you can just looking at the picture? You cannot. Okay. So I think should I give one? Okay, I will wait for 1 more minute. If you are not able to give the answer, what is the type of the distribution layout, then I will give you the options. Okay, let's not make you wait. So these are the options. Whether it is circular or interlaced or tree, that you have to identify. Just observe the arrows. Is it clearly visible? The arrows are they clearly visible? Just follow the arrows. How the waters are getting distributed. So if you just follow the that, you will be able to understand. Okay, I'll see the how just observe how the water is flowing through the arrows. The water is going like this way, then it is like this way. So it's kind of branching, right? If you are not able to understand, tell me. So these are just like branches, and within that branch there are also sub branches. So after coming into this branch, it will get divided into 1, 2, 3 parts. After coming in this branch, it will be divided into 4 parts. After coming in this branch, it will be divided into 1, 2, 3 parts, right? And the first branch, it gets divided into 3 parts: B, S, and B. The number of parts are also there. So when you can, in what kind of system you see these kinds of branches? Sorry, my connection got disrupted. So you understand, right? So where do you see these kind of branches? So it's basically nothing but the tree one. This one, right? So tree is the correct answer for this distribution layout. Now let's move on to our next distribution layout. Can you identify it? Same options. I'll give you the options also. So circular, interlaced, or tree. Which kind of distribution is it? Anyone? Oruna, Dipti, Sureka? Circular, yeah. correctly identified. So what is happening here? If you just observe the arrows, so water is coming, okay. It again got divided into branches, okay. But you just look at the M1. So it is coming, again it is returning also. You can see here it is returning. Now here it is going, but these are adjoining. This is joining here. So there is a joining point here. There is another joining point here. If you look at the S lines, you will see. And from here it is again see returning. So whenever this thing there is a closed loop, then it is nothing but circular system. Okay. So you have correctly identified it. It is as circular. So now the last one, last but not the least. So after this, we'll take 3-4 minutes break, maybe 5 minutes break after this question, and mm, we'll resume at. Okay, so these are the options. So after this question, we will take 5 minutes break, and we'll resume at 8:10. A short bio break. You can stay here, or you can stay here and discuss any concept where you have any doubt, or you can take the break and I can come back at 8:10. Okay, so what is the type of this layout? This distribution layout? Can you identify? Okay, so yeah, interlist. Interlist is the correct answer. We can take the break. We will again meet at 8:10. Please rejoin at 8:10. You may or you okay. Okay, so welcome back. Hope everyone is back. Now we will resume our session. Just wait. Okay, so let's restart. Next question is you have to identify the correct statement regarding water supply pumping operations from among the following statements. Rotary pumps are suitable for the handling of liquids containing suspended matters due to the close fitting on the rotor. Second statement is centrifugal pumps work on centrifugal force. And third statement is in centrifugal pumps, water usually enters parallel to the plane of the impeller. You have to identify the correct statement among them. So two statement will be incorrect, one statement will be correct because it is MCQ, not MSQ. Yeah, one correct statement, I think. Yeah, just tell me the option. Type it in the chat box. Two statement are for rotary centrifugal pump. One statement is regarding rotary pumps. No one. Option C, you are telling as the correct statement. We'll see. Anyone else? Or both of you agree with Deepti? Okay. If no one is showing courage, we will see. So the answer is option B. Centrifugal pump works on centrifugal force. This is the correct answer. So do you people know what is centrifugal pump, what is rotary pump, these things? If you don't know, we can discuss in the next class what are these kind of pumps, how they work, what are their principles and all. I'll note it. I'll discuss regarding rotary pump and centrifugal pump in the next class. So now, if you have studied it, I'll tell. See, the term centrifugal means centrifugal force only. The centrifugal pump, the name comes from the centrifugal force. So that's why option B is the correct answer here. But what will happen for the option A and C? What will be the correct version of them? So it is something like this. The rotary pumps are not suitable for handling liquids containing suspended matters due to the closed fitting on the rotor. In the centrifugal pumps, water usually enter perpendicular to the plane of the impeller. Here it was told a parallel to the plane of the impeller, which is incorrect. It enters perpendicular to the plane of the impeller. Can anyone tell? So let's see. Let's just Google it and just let's see together a picture of impeller pump. So that will be good, I think. How it will enter, you will see. So just Google it. Uh, if you just look at the 3D view, oh, okay, I forgot to share the screen, right? Okay, just that. Just see the no need to discuss in next class again. Just I'll just Google it and just see. Yeah. So where is it? Hmm. Yeah. Just see. So you can see these are centrifugal pumps. You just see one interior. So let's see one. It is one interior of a centrifugal pump where it will rotate. So the water will come. Let's see one more good picture. Yeah. It is not. Okay, this one you can assume as it will be a good picture. So what happens? This is a suction side, this is a discharge side. So water comes like this way, and at the center point you can see there is a hole. Okay, this point, this this things this thing is called as the impeller, and at the center point there is a hole. It is called as the eye of the impeller. Yes, this you can see. So this is called as the eye of the impeller. Okay, these are called impeller vanes. So as it rotates, the water that has entered in this casing, it is basically a cut of the. In generally, the cut is not there; it is complete. So you are seeing the interior of a impeller of a centrifugal pump. Basically, the from outside it looks something like this, or it looks something like this. Okay, so here you are seeing just the interior of the centrifugal pump. So the water comes and it enters perpendicularly to the plane of the impeller. Okay, it doesn't enter parallelly. So if it was parallel, then it was the suction, it would have been the suction side, it would have been the discharge side, but it is not. It is the suction side and it is the discharge side. Okay, so water comes through the impeller eye inside the casing, and through the as the impeller rotates through the impeller vanes, by centrifugal action, the water comes at the periphery of the casing, and then it gets squeezed out through the that is called the discharge side of the impeller. So if you just see one-sided picture of it, you will see something like this. So per, through the perpendicular plane of the paper, the water is entering through the impeller eye. It is rotating by centrifugal action. It is squeezing out and getting discharged. This is how a centrifugal pump works. This is another good picture. So this is the impeller. Impeller casing may be different types. The impeller may be closed impeller, it may be open, it may be semi-open. Different kinds of impellers are there based on the operation. So if the fluid contains a large amount of slurry, then we can use open impeller, open or semi-open impellers in order to prevent the choking of the impeller inside the centrifugal pump. Do you get it? So if the impeller is closed, then there is a chances of clogging the impeller by particles those are present inside the liquid water. Okay, you can see the impeller casings here. So this is basically a closed impeller that you are seeing here. So for the closed impeller to use in a industry, the liquid must be clean. Slurries and your sewage, those things must not be present. Otherwise, it may clog the centrifugal pump. So hope it is clear to you. Now we will resume. So I'll reshare my screen. Hope it was visible. The screen was visible. I didn't look here whether it was visible or not. So I think it is now clear. If still there is any doubt, you can ask. So option B is correct in this case. Now we'll move on to our next MCQ. Which item among the following are open channels supported above the groundwater trestles? Option A is aqueducts. Option B is pressure pipes. Option C is flumes, and option D is circular sections. So I'll wait for 2 minutes to type the answer option in the chat box. So one of the following are open channels, right? And the other three will be closed channels, basically. And by the name itself, if you just observe the name very carefully, you will be able to answer. Maybe two options will just get eliminated like that way from the name itself, because they will form a closed channel. I'll wait for 1 more minute. Please try. Okay. Deepti is telling us option C, flumes. Any contradictions? Or other Aruna and Sureka agree with Deepti? Okay, okay. Sureka is telling us B, pressure pipes. You see, the thing is that pipes, what do you think? Pipes are closed or open? Pipe is closed, basically. Circular channels are also closed things. Circular is basically the cross section. So circular and pressure pipes, these two options just gets eliminated from the name itself. So they cannot be open channels. Open channels means just like open drains you see at the side of the road. So those are kind of open channels. Okay. So option B and option D cannot be the correct answer. So whatever Dipti has told, C, flumes is the correct answer. So these flumes are the open channels supported above the ground over trestles. Okay. Option C is the correct answer. Now we'll see different types of flumes. So this is how the flumes look like. You can see for household drainage purposes, from the side of the hill or mountain, for the purpose of flowing the water. This is how the flumes look like. Okay. So now we will move on to what? Or we will move on. We will move on to our next MCQ. Renewable resources must be used no faster than the rate at which they regenerate. Is a statement under option A, the Dublin Statement on Water Sustainability, option B, OECD policy objectives, option C, the Delhi rules for sustainability, option D is none of the above. Type the answer in the chat box. Hope fumes was it was clear to you. Option B, OECD policy objectives. Sureka is telling. Not you. Okay. You can understand the statement, right? Okay, so this is just a memory-based question. There is nothing to. I mean, no concept is there. It's just memory-based question. So renewable resources must be used no faster than the rate at which they regenerate is a statement under the Delhi rules of sustainability. Option C is the correct answer. What is OECD basically? It is Organization for Economic Cooperation and Development. So the objectives of OECD are fostering economic development, prosperity, equality, opportunity, and well-being for all, and fighting poverty through the promotion of economic stability and cooperations. The OECD has been signed by 38 member countries. India is a participating partner in policy discussions in OECD bodies and takes part in regular OECD surveys. But as of 2023, India was not a member country. This year, discussions are going whether to make India a member country or not. Let's see whether we become a member country or not. But as per last year's data, published data, India was not a member country of OECD. Now, STR, Services Trade Restrictiveness Index ranking, STR index ranking basically was based on presence of market restrictions. So based on the STR index ranking, the first four countries are Japan, UK, Netherlands, and Czech Republic or Czech Republic, yeah, Republic of Czech, Czechoslovakia, yeah. So India ranked based on this index, India ranked 47th after Israel, which rank was 46, and before Russia, Thailand, and Indonesia, whose ranks were respectively 48, 49, and 58. So now we'll move on to our next MCQ. Which one of the following pairs is incorrect? Option A, Ganga and with the river, there are certain names of the states. There's like Uttarakhand, Uttar Pradesh, and Bihar. Option B, Krishna with Kerala, Maharashtra, and Karnataka. Option C is Kaveri with Tamil Nadu, Karnataka, and Kerala. And option D is Godavari with Karnataka, Andhra Pradesh, and Chhattisgarh. Essentially, what this means is they are telling about this particular river which is flowing through certain particular states. So whenever you find a river which is not flowing through an associated state which is mentioned, which name is mentioned beside the river's name, that will be the answer. So yeah. Mm. Which one do you feel is incorrect? Okay, I will proceed with the answer. So the Krishna River originates in the Western Ghats near Mahabaleshwar in the state of Maharashtra and flows through Karnataka, Telangana, and Andhra Pradesh. Krishna River doesn't flow through Kerala, which is the incorrect option in our case. Okay. Now we'll move on to our next MCQ. Water is allocated to the most beneficial uses for meeting option A, environmental sustainability, option B, economic efficiency, option C, social concerns, and option D is resource conservation. Type the correct answer in the chat box. I'll wait for 1 minute. Okay. So what is the correct answer? The explanation is something like this. Economic efficiency of sustainable water management is concerned with allocation efficiency of water resources involving no or minimum wastage, along with regulations for ensuring optimal risk allocation among the stakeholders. So option B, economic efficiency, is the correct answer. Okay. Next MCQ. The ephemeral rivers are short-lived rivers which originate due to heavy rainfall and are marked as option A, the coastal rivers, option B, the rivers of Deccan Plateau, option C, the rivers of inland drainage basin, option D, the Himalayan rivers. Do you want to say something, Sureka? Okay. Again, I'll wait for 1 more minute and then today mostly MCQs are there. In the next class, again we will uh, do some problems. Okay. So the explanation is the ephemeral rivers are short-lived rivers which originate due to heavy rainfall and drain inland. Luni in Rajasthan is an example of such ephemeral river. So option C, the rivers of inland drainage basin, is the correct answer. So the ephemeral rivers are marked as the rivers of inland drainage basin. Now next MCQ is sustainable management of water resources involve option A, free water services for basic human needs. Option B, unlimited use of water for activities beneficial to human. Option C is meeting current water needs without compromising the opportunities of future generations. And option D is singular decision making. Let's type your answer in the chat box. Do you know what a sustainable management means? Sustainable, these are very buzzword nowadays. Sustainability is something, any technology or any human system which lasts for a longer period of time, and not only it lasts for a longer period of time for itself, but also it doesn't affect the environment. So sustainability covers three main aspects. One is technological aspect, another one is economic aspect, and another one is social aspects. Economic, environment, and social, and also technological. Yeah. So four aspects it covers sustainability. It's basically human technology, which not only lasts for longer period of time, but also it sustains the environment, uh, the economy of a particular region, and also the social demands of the people. It also fulfills. So for these three aspects, economic, social, and that is your environmental, all these three are also fulfilled for longer period of time, not only the technology itself. Then we can call something as sustainable. Otherwise, it is not completely sustainable. So if we want to do sustainable management of water resources, it will involve which one of the following? Surek has given answer as option D. So we'll see the explanation. Sustainable water management ensures meeting current water needs without compromising the future ability of resources to meet the needs of future. So option C is the correct answer. We'll see that you have heard about electric vehicles, right? So can any one of you tell why people say the conventional vehicles which use petroleum resources or deep resources which can deplete over time, so they don't call it sustainable? Why they don't call it sustainable? Because once the fuel gets depleted in nature, you cannot run that vehicle, right? But people say that electric vehicles are sustainable. So can you say that, do you agree with that, whether electric vehicles are completely sustainable or not? Anyone? You have heard about the electric vehicles, right? So some of your father or mother may have scooty or something, which is uh, which is a electric scooter. It may be Ola S1 is kind of electric scooter. So can we call it completely sustainable? Though it is out of syllabus, it is not related to water. But yes, water management also the sustainability concept is there. So the thing is that you cannot call it completely sustainable. It depends on from where the electricity is coming. If you are recharging the vehicle with electricity that is getting generated by using fossil fuels like coals, then it is not sustainable at all. But if you are recharging the vehicle with electricity that has been generated from solar energy, or let's say wind energy or nuclear energy, then you can call it sustainable. That I can tell you. Yeah. So now we'll move on to our next MCQ. Which one of the following water body contributes maximum to the atmospheric moisture? Option A river, option B ocean, option C lake, and option D is pond. You can type your answer in the chat box. Okay, I will give the answer. So the explanation is evaporation from the ocean contributes 90% to the atmospheric moisture. Why? Because ocean has got a larger surface area. The more the surface area, the more is the rate of evaporation. So that's why river, lakes, and ponds don't contribute to the atmospheric moisture much as compared to ocean, because the more the surface area, the more will be the rate of evaporation. Okay, so we'll move on to our next. So ocean is the correct answer. Next MCQ is under the action agenda of the Dublin statement, just that we just discussed earlier in one of the earlier questions. The better access to a potable water supply and sanitation services to rural population was regarded as option A, an immense task but not an possible one, not an impossible one. That means immense task but possible. Option B is a close to impossible task. Option C is an easy task if society demands for it, and option D a very easy task if the state has willingness. So sometimes you can see this demand of the society or the willingness of the state can make a task easy. And easy for whom? That is also another question. Okay. So we'll focus on our MCQ. What was the action agenda of the Dublin Statement? Okay. Surekha is telling us option C. We'll see the answer. It's just a memory based question. Even if we're wrong, no issue with that. So the explanation is the rural population must also have better access to a potable water supply and to sanitation services. Right? Not only the urban population, but also the rural population should have. So it's an immense task, but not an impossible one, provided with the appropriate policies and programs are adopted at all levels, that is local, national, and international. So option A is the correct answer of the Dublin Statement. Basically, you can see the rural, why the urban planning is required. So whenever the urban areas are already developed, however, we cannot redesign it's a basically difficult task. In Delhi areas, you can see how the water clogging is occurring, how the flooding is occurring due to heavy rainfall, due to improper design. But we cannot grieve every each and every time. We cannot blame every people for these mistakes. What we can do, we can learn from our past mistakes and we can design the rural areas which are getting upgraded to urban areas gradually, and we can design the water system of the new cities like this way. Okay, so our next MCQ is most of the rainfall in India is caused by which monsoon winds? Option A is southeast, option B is northwest, option C is southwest, and option D is northeast. It's a pretty general knowledge question. Wait for 1 minute. Then we will answer. Which state do you think experiences the highest rainfall in India? It is the state of Meghalaya. The term Megh in English it means cloud, and Alloy means it is house. Right? It's a house of clouds. The term Meghalaya, the thing is like that, or the resting place of the clouds. The name of the state came because of this heavy rainfall only. The Moshinram is a place of the Meghalaya where the highest rainfall occurs. The monsoon winds actually gets hit by the Himalayan region, and then it Himalayan mountainous range, and then it makes the rainfall. So The wind basically comes from the southwest side. Southwest monsoon winds are the rain-bearing seasonal winds that flow from the Arabian Sea towards the Indian mainland in the southwest direction and leads to most of the rainfall in the period between June to September. So southwest is the correct answer. But here one wrong thing is mentioned. So it will from the Arabian Sea towards India's mainland in the it will be northeast direction, not southwest direction. From southwest to the northeast direction. So as it gets generated from the southwest direction, that's why it is called as the southwest wind. So our next MCQ is which one of the following included in the guiding principles of the Dublin Statement on water sustainability? Option A is water should always be sold as an economic good. Option B is water allocation should be priorities should prioritize the uses with the highest financial returns. Option C is users should be the primary policymakers for sustainable management of water. And option D is women play a central part in the provision, management, and safeguarding of water. So we can see that the water should always be sold as an economic good. The option A and option B, water allocation should prioritize uses with the highest financial returns. These two cannot be the correct statement. Why? Because one statement that international organizations are coming together and signing that can declare things like this way that you should use water just for profit making, just as an economic good. It cannot be the outcome of these statements, right? Common sense says that. So either it will be option C or it will be option D. Let's see the explanation. So the third principle of the Dublin Statement on water sustainability states that women play a central part in the provision, management, and safeguarding of water. Other given statements are not fully correct. As a matter of fact, because it must be regarded as economic good for competing services only. It cannot be the correct statement, as I told earlier. And users can't be the primary policymakers. Option C cannot also be correct. Why? Because if the users, if the users are policymakers, then also they are maybe biased because biased based on their usages. So that's why they cannot be the policymakers. Only the representatives of a democratic country who are the representative of the public or the users, they can make the policies. But it is true that users must be engaged in the policy making process. Okay, they cannot be the primary or prime policy makers, but they must be engaged in the policy making process. Their opinion must be taken. So option D, women play a central part in the provision, management, and safeguarding of water. It was the third statement of the Dublin statement on water sustainability. So all of you who joined this class today are women. That it's a very sad thing that in the medical profession, especially for women, certain attacks has been occurred in the state of West Bengal. So we stand with every medical professions, medical uh, be a doctor or non-doctors, whoever in the medical profession, we stand with them and we support their struggle for making the system robust and fault-free, so that this kind of incident don't occur in the future, right? So now we will move on to our next. So what is the Dublin statement basically? We are just talking about the Dublin statement. It's just a memory based question. So you should know it's a very important statement based on water. So that's why. though it is not in the syllabus currently. Still, I wanted to include it just for your knowledge. So the Dublin Statement on Water and Sustainable Development, also known as the Dublin Principles, was a meeting of experts on water-related problems that took place on the January 31st, 1992 at the ICWE, which is International Conference on Water and Environment in Dublin. Dublin is the capital of Ireland, and it was organized from January 26th to January 31st in the year of 1992. So the Dublin Statement on Water Sustainable Development recognizes the increasing scarcity of water as a result of the different conflicting uses and other uses of water. The declaration sets out recommendations for action at local, national, and international levels to reduce the scarcity through the following four guiding principles. What are they? The number one guiding principle was fresh water is a finite and vulnerable resource essential to sustain life, development, and the environment. The second guiding principle was water development and management should be based on a participatory approach involving users, planners, and policymakers at all levels. Number three was, it was the last question, women play a central part in the provision, management, and safeguarding of water. And number four is, water has an economic value in all its competing uses and should be recognized as an economic good. But what the option told? It was the option told that for highest profit making. So you cannot use the water for profit making purposes. So it was the incorrect option. But it should be recognized as an economic good because for purifying the water, water is free, but purified water is not free. Drinking water is just 3% of the entire water, or even not that one. Now it has been decreased as the glacier, not only the glaciers but also the icebergs. Those are being melted and being mixed with the salty ocean water. It is not drinking water then, right? So that's why to purify the water and to purify it up to the drinking level, it requires energy and money. So that's why must be recognized as a economic good. But yes, it should be distributed keeping the service nature of the water in mind, not entirely as a profit making commodity. Okay, so now as per the international norms for global water distribution, for water scarce country, the per capita availability of water must be less than 10 LLPA. For water stressed country, the per capita availability of water should be in between 10 to 17 LLPA. And for water adequate country, the per capita availability of water should be more than 17 LLPA. The term LLPA means lakhs of liter per annum. Okay, per capita means per head availability of water. So if the per head availability of water is less than 10 LLPA, then we can consider that country to be a water scarce country. If the per capita availability of water is between 10 and 17, then we can say it to be a water stressed country. If the water availability per head is more than 17 LLPA, lakhs of liters per annum, then we can consider it to be a water adequate country. So India is not a water adequate country. It is gradually shifting from water stressed to water scarce. So that's why the water planning, water management, and how we distribute the water so that there is minimal loss, and from where we are collecting that water, what are the sources of water, those things we have to be very serious about to prevent India from switching to water scarce country from a water stressed country, right? We should hold India there at the stress level and gradually make it move towards the water adequacy, right? So now we'll move on to our next MCQ. So evaporation value is affected by option A, air temperature, option B, humidity, option C, wind speed, option D is all of the above. We saw in our last question, last not in few of the earlier questions, we saw that ocean is the largest contributor to the uh, evaporated, to the moisture that is present in the air. So why a water body, how a water body basically contributes to the atmospheric moisture? The process is basically called as the evapotranspiration. And if you decrease the humidity of the air, the evapotranspiration will increase. If you increase the humidity of the air, the evapotranspiration will decrease. Just like we see just at the beginning of the just at before the starting of the rain, we see that our body is getting perspirated, right? We get a lots of perspiration because evapotranspiration rate becomes low at that time because of the high presence of humidity in the air. So humidity is a contributing factor. Air temperature, if you increase the temperature, the evaporation rate will increase. If you decrease the temperature, evaporation rate will increase. So air temperature is a factor. So if two factors get satisfied, then option D is the correct answer. So wind speed also contributes to the evapotranspiration. So wind speed is kind of sweeping. It's sweeping away the uh, moisture from above the water bodies. Okay, so it thereby increasing more wind speed means more evapotranspiration. Less wind speed means less evapotranspiration. So all of the above is a correct answer. So explanation is something like this: the principal water weather patterns affecting evapotranspiration are radiation, air temperature, humidity, and wind. And all of the above is the correct answer. So now you have to identify whether the following statements are correct or not. Statement 1 is trade-off between policy objectives of sustainable water services are often forced due to conflicts in sustainable water management. And statement 2 is an example of trade-off between social concerns versus economic sustainability could be a decision on whether to prioritize water allocation for domestic uses or to high value uses like industrial processes. What is the time left? Okay, 1 minute is left. So we'll stop this session after this question, maybe. Yeah, we'll stop this session after this question. Try to answer which statement is correct and which statement is incorrect. Okay. Anybody know what is able? I'll move on to the answer. So the explanation is something like this: prioritizing water allocation for domestic uses is a social concern, while prioritizing high value uses like industrial processes are in favor of economic sustainability. So both the option are incorrect in our case. Okay, so we'll stop the session here. If anybody has any doubt, You can ask questions. Otherwise, thank you. We will meet on September 1st, next Sunday. Okay, good night.